Everyone, and welcome to day 2 of lesson 7.2, which is we're dealing with angles in the unit circle. Today we're going to talk about angles in degrees. We're also going to learn about something called radians. Okay, really start filling in our unit circle, being able to understand what the unit circle tells us, how we can convert between degrees and radians, and understand all of the different information. So we're going to start day 2. We will start with a warm-up. So I want you to use the special right triangles to find the exact values of the sine of 30 and the sine of 60 and the cosine of 30 and the cosine of 60. And I want exact values. So I don't want decimal approximations. None of these answers are going to have decimals. Then I also want you to find where the sine is positive and where's the cosine positive. What quadrants would those be? So pause the video, do a few minutes of thinking, write down your ideas, and then we'll check. Okay, so let's take a look. Okay, the sine of 30 and the cosine of 60 are both 1/2. Okay, and the reason that is let's see the triangle. Okay, we could draw the 30, 60, 90 triangle. And we talked about how if it was a unit triangle, if the hypotenuse is 1, then across from the 30 is 1/2. And across from the 60 is square root of 3 over 2. So sine of 30 would be opposite over hypotenuse. Okay, we learned that the sine of 30 is the same as the cosine of 60. And if you didn't know that, we could set up the triangle, do adjacent over hypotenuse. Same thing with sine of 60 and cosine of 30. And we learned last time that sine is the height function, and the height is the y values, and the y values are positive in quadrants 1 and 2. And cosine is the x values, and the x values are positive on the right side, which are quadrants 1 and 4. So if you start making these connections, then the unit circle is comprised of a bunch of details of what is sine and what is cosine and where's the angle. Okay, where sine is the height, so sine is positive, we said, in 1 and 2. And cosine is the x, so cosine is positive in 1 and 4. Now eventually we'll get to what is tangent, but the hypotenuse is always length 1, and we can use our special right triangles, our 30, 60, 90, and our 45, 45, 90 triangles, to find all of the lengths, all of the xy coordinates for all of those special angles, the 30, the 45, the 60 in the first quadrant, or angles in the second, the third, and the fourth quadrant. Now, in mathematics, we don't always like measuring in degrees, so we use something called a radian. So what a radian is, it's a measurement of an angle, but we use the radius of that circle. So let's say I took a circle, I folded it into half and half again, so I got a quarter circle. This length would be my radius, this red segment. If I bent this red segment, it would get from here to here on the circumference of the circle. So I'd have 1 bent radius and 2 and 3 and 4 and 5 and 6 and a little extra. And we're going to figure out exactly how much extra it is, and we're going to relate it to something you've seen previously. But a radian is really a measure of how long the radius is. We're going to see that there's 6 plus radii, or 6 plus radians of a circle. Okay, and this is going to come from a formula that we know and we've seen. Okay, so what is a radian measure? Once again, there, that orange segment, okay, and we're going to learn this angle outside is the same as this angle inside. This is 1 radian. Now, if we take the full circle, we're going to see that this spot over here on the left side is pi radians. Half the circle is pi radians, and the full circle is 2 pi radians. It's either 0 or 2 pi. Just like in degrees, we could have 0 or 360, both end in the same position. Now think about what formula have you used that has 2 pi radii, or 2 pi radians? Okay, maybe you thought about it. Okay, so the radian measure, okay, the definition is the radian measure of the central angle is equal to the length of the arc subtended by that angle. We use a radius to measure that. Okay, so that is 1 radian. The radius of the unit circle is 1, and the circumference is 2 pi. So circumference equals 2 pi r comes from this idea of what a radian is. So the circumference, the distance around it, is 2 pi radians. So no matter how big your circle is, your circumference is about 6.28 times the radius, no matter whether it's a giant circle or a small circle. Now, if the full circle is 2 pi, half the circle is 1 pi. Half of that, which is a quarter of the circle, is pi over 2. And we can count by half pi. So half, 2 halves, 3 halves, and then 4 halves, which is 2 pi. So we need to know these measures. If we know where pi is, and pi is equal to 180 degrees, and pi over 2 is equal to 90 degrees, we're going to start being able to figure out where the angles wind up if they're in radians instead of degrees. We need to get comfortable with that instead of always having to convert to degrees, because that's a lot of work. Okay, so once again, this is just saying, well, how do I know where an angle is? Well, if I look at pi over 4 is less than pi over 2. I look at my unit circle, I always have pi over 2 and pi written down. And if pi over 2 is right here, then pi over 4 is half of that. So pi over 4, we're going to learn, is the same as a 45-degree angle. So we're going to be able to sketch these. So how can we use them to sketch it? Well, if we know where pi and pi over 2 and 3 pi over 2 and 2 pi are, we can figure out which quadrant we're going to be in and how to sketch it. So let's look at the angle 4 pi over 3. So we're going to figure out which quadrant 4 pi over 3 is. Then we're going to draw it. And we're going to draw it as accurately as possible. So I look at this, and the first thing I notice is this is more than pi. 4/3 is more than 1, so it's greater than pi. And I know pi is on the left side of my unit circle. So I know I got to be in at least quadrant 3. And I know 4/3 is a fraction. 4/3 is less than 3 halves. So if it was 3 halves pi or bigger than that, then I'd be in quadrant 4. So this is telling me I'm in quadrant 3, which is exactly what this is saying. It's greater than pi, which is on the left side, but it's less than 3 halves pi, which is at the bottom. So it has to be in quadrant 3. And we know it's pi over 3 more than pi. Okay, it's 1/3 more than 3/3. So pi over 3 we're going to learn and get very comfortable with, that pi over 3 is up here. So if we have pi, we can add pi over 3 and get that dot is at 4 pi over 3. And it's got a reference angle of pi over 3. And then we're going to extend this eventually to the fact that we know that sine of 4 pi over 3 is negative because it's got a negative height. And if I know the sine of pi over 3, then I can find the sine of 4 pi over 3. Okay, and the sine of pi over 3 we're going to learn is square root of 3 over 2, which would make sine of 4 pi over 3 negative square root of 3 over 2. They have the same magnitude, but sine of 4 pi over 3 is negative because it's got a negative height. We're going to start making all those connections. But first we need to visualize where the angles are and which quadrant they're in. So that's what you're going to try. Okay, you're going to start with that. Where is negative 5 pi over 6? Think about that unit circle, draw the unit circle, and think about it. Is it in quadrant 1, 2, 3, or 4? And roughly, where is the terminal point? Okay, so hopefully you've tried sketching it and thinking about is it in quadrant 1 or quadrant 2 or 3 or 4? And the correct answer is it's in quadrant 3. Now my angle ain't perfect, okay? Mine's a lot closer to the center. It should be a lot closer to pi, okay? It's almost, so if this was negative pi, it would be 1/2 rotation backwards, but this is less than half a rotation, so it should wind up in angle 3, probably closer to pi, or this is also negative pi than I drew it. Okay, so I should see that negative 5 pi over 6, okay, has a reference angle of pi over 6. Okay, its body is pi over 6 in the first quadrant. So it's got the same height as pi over 6, but it's got a negative height. It's got the same x coordinate as pi over 6, but the x coordinate's negative. Both coordinates here are negative, so the sine of negative 5 pi over 6 and the cosine of negative 5 pi over 6 are both negative. We're going to make those connections. Now, a question might come up, and knowing this conversion is really nice. Maybe I want an angle in degrees that is currently in radians, or I want it in radians and it's in degrees. So how do I do that? Now, we already know some angles in degrees and their conversions to radians. So here's the 5 that we know right away, and these are the 5, like I'd say, most important ones. Okay, 0 radians, 0 degrees, starting point. 90 degrees and pi over 2, top of the circle, 180 matches with pi, and 270 matches with 3 pi over 2. And then they never write it on here, which frustrates me. 360 degrees and 2 pi are the same. So now to convert between degrees and radians, we can set up a proportion. Okay, and I like using this middle as a proportion, that pi is 180. So the way I write it, my proportion, I always write that the degrees over 180 equals the radians over pi. Now they're going to give me one or the other. They're either going to give me the degrees and have to convert to radians, or radians and convert to degrees. This proportion will work for no matter which one you give me. Give me one, I'll find the other. Now there's other so-called shortcuts of, well, when do you multiply and when do you divide? But I think the proportion is really efficient. Conceptually, I understand it. It's saying, well, if 180 degrees equals pi radians, then what is 60 degrees in radians? Or what is pi over 4 radians in degrees? Now, the book teaches it slightly different. Okay, it uses a conversion chart, which is fine. So it says to go from degrees to radians, you multiply by pi over 180, which is what the proportion is going to do. And to go from radians to degrees, you multiply by 180 over pi. Now, I confuse those and get those backwards, so I'd always recommend just setting up the proportion, solving the proportion, taking that one extra step, and eventually, when you get familiar with them, you're going to know, okay, pi over 3, 60 degrees. Pi over 4 is 45 degrees. 3 pi over 4. Okay, you'll know that's 135 degrees. And you'll just start knowing those familiarities because you'll have done all of the special angles that we're going to deal with. And then some of the stranger angles, like pi over 7, I don't know pi over 7, what is in degrees. So to convert, what I would do, I don't like this multiply by 180 over pi because I forget. I say, well, pi over 7 relates to pi as how many degrees relate to 180. And then I'm going to solve a proportion. So I do cross product and get 180 pi over 7 equals d times pi. And then the pi's cancel out. And I'm left with 180 divided by 7 degrees. And if I want to convert that to a decimal, I can divide. I can do 180 divided by 7 in my calculator. 75 degrees convert to radians, I can do the same thing, where 75 over 180 is equal to how many radians over pi. Now in this case, I'm going to do cross product and then isolate the variable. So I get r equals 100 equals 75 over 180 times pi. I can leave my answer like that. I can simplify it to 5/12 pi as well. I don't need to remember, is it multiply by pi, divide by 180, or backwards? I set up the proportion. I'm great at solving proportions, and I can think I'm going from degrees to radians. I have my ratio for degrees, my ratio for radians, and I can convert. But if you want to memorize the so-called shortcut, go for it. As long as you get it right and understand what you're doing, either method works. So pick a method, try it out. Convert 112 degrees to radians, and convert pi over 6 radians to degrees. And when you're ready, unpause the video, we'll check the answers, and then we'll see what all that we've learned today. Okay, so here we go. Take a look. Those are the answers, 28 pi over 45 radians. Okay, that's as simplified as it's going to get. And then pi over 6 radians is 30 degrees. That's a special angle. You should be very familiar in the upcoming weeks with pi over 6 and pi over 3 and pi over 4. We'll continue to talk about them. So in 7-2, we've learned about the terminal side and we've learned about reference angles. So how far is the angle from a horizontal, because we want it to be a first quadrant angle. We learned about sine and cosine, with sine being the y, so sine is positive up in the first and the second quadrants, and cosine being the x, so it's positive on the right side, and how to convert between radians and degrees, and how to start filling out this unit circle. Now, I would have a unit circle printed out, and every day I'd fill a little bit more in. Where are the angles? What are the coordinates? So that I know what the sine of 30 and the sine of 60 and the sine of 45 and the cosine of all of them is. And I'd also practice converting between radians and degrees. And as you gain information bit by bit, you're going to learn that the unit circle really is our friend. It really is helpful if we know one piece of information at a time, and eventually we can put together the whole story. Now we'll continue more of that in lesson 7-3.